Okay, so a few thoughts on, when we are in 2035 and look back what made the key aspects so that it unlocked all the molecular motors field and power our devices. So one of the key things which I think we mentioned is that, if you look at all the talks you see at these types of conferences, you will see many people using DNA origami. But if it comes to all the cool motors we have seen today, it's usually one or two groups that use them. Why? Because it's so difficult. It's usually group specific to make it work. You need something which is as simple as DNA origami, where a computer science student can learn the supplementary, order the strands, and mix them together. And we need the same easy modular approach for motors as well. So we need some standardization, making the components work together. So plug a molecular motor to be able to bind to your proteins of choice or to your DNA origami of choice. So making things interoperable and better component linkage is a key aspect to go from one group that knows how to do it to anybody in the field being able to download it and incorporate it into their system. That goes with the expandable library of inputs that your models can react to. So we've seen light, we've seen chemicals being absent or present as the driver motions, but you also want them to be activatable, and they're activatable by force. You want them to be able to be orthogonally controllable. So if you have 4 motors, you want one of them to be switched on and switched off, while others can still be running. If you have just ATP-powered motors, they all consume the same ATP and they're all active. If you shine the light on your sample, all of them move. So we need individual motor control, which comes back another point is amplification to macro scale. If each motor is moving in random direction, you need to, synchronize them, position them precisely, make them all pull in one direction to amplify their readout. And having some feedback control, right? So if you fly a plane, you basically need to adjust the direction. You also need to have immediate feedback control to modulate the motor operations and coordinate them. And it was brought up that US is a capitalistic country, so there has to be a near-term, unless you're in academia, then you don't need practical application, but there's a need for near-term commercial application vision, what these motors can do, it would be useful. That probably 2035, looking back, we would see, this was this thing that became actually useful and that drew all the interest and more investment into the field. I think that summarizes our group's thoughts, but if everybody wants to add something, please.